In this tutorial, use RayTK to build a scene with some polyhedrons and some neat material stuff. The scene is based on one that I made recently that just sort of evolved without a specific plan, so it ends up in a fairly different spot from where it starts, but hopefully it's an interesting journey. There will be several points through the process where it might make sense to save out a separate copy of the project so you can take it in a different direction later. I'll point those out as we get to them. You don't need any prior RayTK experience, but it may still be helpful to check out the first few videos in the intro series, or you could do that afterwards. I'll be using RayTK version 0.44, so just make sure you're using at least that version. Check the video description for a download link. I'll also be providing a project file download for the scene for Patreon subscribers, and there's a link to that in the description as well. The first step is to load the toolkit talks into your project. I do that at the root of the project outside of the main project comp so that you can avoid having a lot of these data connection lines between that and every operator in your scene, because I find that to be visually confusing, but if you want to stick it in project 1, go for it. When you're done with that, head back into project 1. Open the RayTK palette with Alt-R. If that doesn't work for you, there may be a setting on your GPU. If you have an NVIDIA one, if it pops up some sort of overlay, there's a setting in the NVIDIA app where you can disable that. Or you can go to the component talks, and it has these two parameters for keyboard shortcuts, so you can swap those to something else if you want. Anyway, once you get that working, open the palette with Alt-R, and we're going to create a RayMarch render 3D. And then drag out from the first output to create a null top so that you can see the rendered image. To preview things, you could either switch on the display flag to show it in the background of your network, or you could right-click it and open a viewer. I'm going to be using this preview panel on the side just so that things fit well in the frame for recording, but use whatever technique works for you. If you're curious about what's going on in the side panel and how that works, there is a template file download on my Patreon. Next, we need to add the camera. So select the renderer and open RayTK's Editor Tools menu with Alt-Shift-R. And then under Add Camera, choose Look at Camera. On the camera, set the FOV angle to 70 and the position to -2, 3, and 5. The contents of the scene is going to be based on a polyhedron. So open a palette and create a Polyhedron SDF. There are a few different similar operators that produce different kinds of polyhedron-like shapes. They each have different features, and we're going to be using some that are specific to this particular one, so just make sure you're getting Polyhedron SDF and not one of the other similar ones. Connect that up to the first input on the renderer. This operator produces polyhedron shapes that are composed of a few different parts. The type parameter here allows us to choose between different types of polyhedra, with larger values producing kind of more detail, more facets, and lower values being less detail. Let's set that to 4. The U, V, and W parameters shift different parts of the reflection planes that are used to make the polyhedron, and so that those will make certain parts of the shapes larger or smaller. But let's keep those all at 1. The radius controls the overall size of the polyhedron, and we can also just keep that at 1. Then we get into the individual parts of the shape, each of which has a toggle for switching it on and off. The faces are the kind of filled-in body of the shape, and it also has its own radius setting, so you can make it smaller than the other parts if you want, but let's leave those at 1. Then segments are the edges, the little tubes that go along each edge. And again, that has a radius to kind of make it larger than the main shape or smaller. And then the segment size here controls the thickness. Then there are the vertices, which are spheres that show up at each of the corners. And so if you make the vertex size a little bit larger, you'll be able to see those. Next, there are settings for how each of those parts are combined. These are going to be the same as the options that you see on combine operator. Right now we're using simple union, which just gives us the combined area of all the shapes. But we can change that to something else like smooth union, and that will blend out those transitions between the different areas. There are also a whole bunch of other options in there, but we're just going to stick with smooth union for now. To optimize things a bit, let's lock in this combine mode setting. So right click on that parameter and choose toggle read only. So this will kind of bake that selection into the shader, which is going to make things run faster. If you're curious about how and why to use that technique and which parameters it can be used on, there is a video in the optimization series that covers that in detail. Below the combined settings, there are a bunch of inputs where we could provide fields to customize the different properties of it, but we're not going to be using those in this video. So giving ourselves a little bit more room to work with here. Another interesting feature of the Polyhedron SDF is that one of the inputs allows you to provide a different shape to use at each of the vertices. And to make it a little bit easier to see what's going on, let's go over to our camera and then just drop the FOV angle to 50. And we can adjust that later once we've changed the rest of the scene and we get more of a sense of the scale that we want to be viewing. We can provide our own shape to go on each of those vertices. So just for demonstration purposes, let's create a box frame SDF and mouse over the different inputs on the polyhedron until you find the one for vertex shape. And note that the ordering of these might change in different versions of the toolkit, so it's important to mouse over them to make sure you're getting the right one. So wire that up to the box frame, and we get something going on there, but it definitely does not look like a copy of that shape on each corner. So what's going on here? On the box frame SDF, let's drop the scale down to around 0.1. And then you can drop the thickness until you can see the actual edges of the shapes there. So now we're getting a full copy of that shape on each of the corners. If we then slowly bring up the scale on the box frame, you'll notice that things are getting cut off at the halfway point between each of the vertices. So when you had a box here and you had a box here, when they get to that midpoint halfway, it gets cut off. This is similar to what you would get with a reflect operator or a modulo polar with mirroring. So when the scale of that shape is really large, or relative to the shape of the polyhedron, then we end up just getting like a tiny part of each of those shapes, and a lot of it gets cut off. So that's why we're not even seeing those kind of sidebars on each of those shapes. One nice thing about that, though, is that because of this mirroring, a shape on one side is always going to line up with a corresponding part of the shape on the other side. So let's create a rotate and then insert that between the box frame and the polyhedron. So now on the rotate, try changing the different parts of the rotation for each axis. So you'll notice that you always have a mirrored part of each shape on the other side. So just kind of zooming into the image viewer here just to demonstrate. So no matter what we change this rotation to, things are always going to line up. And that's nice because it helps us avoid situations where a shape is getting cut off, but there's nothing on the other side to match it. You end up with that kind of gap that the ray marcher doesn't really know how to handle well. The box frames that we have here are kind of neat, but doesn't really visually keep the theme of the polyhedron there. So let's swap out a different shape. So let's create another polyhedron SDF. And again, make sure you're getting that one, not one of the other similar ones. And swap that in place of the box frame. And we can just delete that. Similar to with the box frame, we need to reduce the overall size of that shape that's going on each corner so that we can see it distinctly. So let's drop the radius on this down until you can see at least some of the distinct shape for each one. And do that to, like, let's say 0.2 or 0.3. So there's a little bit of overlap, but you can still kind of see some of the detail there. For the other settings, you can try out different combinations of elements. So if you want to, get rid of the faces and have them be kind of hollow, you could do that, or increase the size of the vertices, or get rid of those entirely. Play around with that a little bit and see what looks good to you. And when you are done doing that, you can also mess around with the combined settings. I'm going to leave that at just the default of simple union though, but once you've chosen one of those that you like, let's do that optimization trick again. So right click that parameter and choose toggle read only. If you now try changing the rotation, now that we have a more interesting shape on there, we'll see how you get some really interesting types of motion. And each of the axes provides a kind of distinct feel. Later on, we'll add some animation to those. But if we want to kind of crank things up a notch and get really interesting, let's toss in an iterated transform. So open the palette and create an iterated transform, and then insert that before the rotate. This operator is a whole topic of its own, and there is a video in the intro series that gets into a lot of detail about it. In short, it applies some transformation and then does mirroring and then does more transformation and more mirroring and so on, and repeats that process a few times. So now on this one, if we try changing the rotation, we get some really interesting results. So you can play around with that, find some combinations that look good, but later on, we will add some animation to these. Keeping this other rotate operator in place after that allows us to still get that kind of coherent motion where it's pulling in or out of different parts of the main shape, while still having the kind of detail that we get out of the iterated transform. This could be another point where it might make sense to split off a copy of the project and try different kinds of transformations in there if you want. Next, we'll take this whole thing and repeat it to form a ring. One approach for that would be with something like a modulo polar that tiles things around an axis. But there's also modulo toroidal, which instead of making just one ring around the axis, repeats the shape in the pattern of a torus, basically a ring of rings. So let's create one of those, so modulo toroidal, and insert that after the second polyhedron SDF. Connect that up to the renderer. Then change the axis here to Z. And then if you bring up the radius parameter on that, it will spread things out until you get more of a coherent ring. You can also adjust the thickness, which will kind of spread out the thickness of that arrangement of the shapes in the torus. But I think the default of 0.2 looks pretty good, so I'm just going to keep it there. So to give ourselves a little bit wider of a view now that we have our shape taking up more space, let's head over to our renderer and to the camera. And now let's bump the FOV angle back up to 70. and then maybe also bring the Z to something like 6. So that gives you more of a view of that whole ring overall. So now heading back over to our Modulo Toroidal, we can see pretty clearly that we're getting 6 repetitions of this shape around that main axis, the center axis of Z. That is defined by the first part of this repetitions parameter, so you can increase that up and you'll get more copies. If you bring it up really high, you can get some really interesting kind of radial looks there, but I'm going to keep it at 6. Then the other part of the repetitions can be a little bit hard to see how many of those we're getting there, but it's 6. Then on the second part of this repetition parameter, you can increase that up, and if you make it pretty high, you'll start to see how things are also repeating around that torus arrangement. And higher values in this can get you some really cool effects there. So this might be another spot where you could split off a copy of the project and kind of focus in on using those in interesting ways. For now, though, let's leave that second part at 12. So that gets some repetition that we can kind of see, in that ring around the torus there. But we still get the kind of distinct shapes in there, or somewhat distinct. Then you can use the 2 parts of the shift parameter to move the pattern of the shapes around either that center axis for the first part, or kind of roll it on the other part of the repetition. We're going to add some animation to this later on to get that kind of continuously opening up motion. Next, we'll set up the material. This is going to start out pretty similar to many of my other tutorials, but we're also going to add a few other types of shaping in there. So let's create a modular mat, but don't wire it up yet. This scene has a bunch of stuff going on in it already, and that means that whenever the shader code changes, like when you disconnect or connect RayTK operators in that graph, the GPU is going to have to compile all that code. And at least in current versions of Touch Designer, when that happens, the whole process is going to stall. Once the scene has fully loaded, things generally run fine, but it can still be annoying to have to wait for that compilation process when you're editing things. One workaround for that is when you know that you're going to be setting up a few new connected operators, you can wire those up, but wait until you're done to patch it into the final render graph. In this case, we're going to set up 4 different shading elements in the material. We're going to wire up each of those, and then after those are all connected, we'll patch it into the scene, and then we'll go through and adjust the settings. With the modular mat selected, open RayTK's editor tools with Alt-Shift-R. And then under Add Diffuse, choose Originaire. Then select the modular mat again, open the editor tools with Alt-Shift-R, and under Add Specular, choose GGX. Then to optimize things a bit, let's select the Diffuse contrib, and then we're going to right-click on the method parameter, choose Toggle Read Only, and then we're going to do the same thing on the specular. So this pairing of a diffuse and a specular, and specifically Originaire and GGX, is pretty standard pairing, and that's what I typically use in a lot of my work. But then let's open a palette and create a rim contrib. And we'll talk about exactly what this is and how it works in a minute. So then let's make another copy of that. So copy the contrib and paste it. So now we have 4 different parts to our material. It will be helpful to be able to have one place where we can toggle them on and off and adjust each one's brightness. And we can do that with the mix fields operator. I'm planning to add a color-focused version of that operator in the next release, so you might be able to just use that instead, but it should be pretty similar to how mixed fields works. So select all 4 of those and open the editor tools with Alt-Shift-R, and then locate mix fields and choose additive. So that will create a new mix fields operator and connect those 4 up to its inputs. Then we need to connect this to the modular map. So let's connect that instead of the first connection there, so the second input, and then we can remove this second connection to Specular contrib since we're already including it there. So now we just have one mix fields connected to the second input on the modular map. So now we can patch this into the scene overall. Take the output of the Modulo Toroidal and connect it to the first input on the modular map, and then take the output of that and connect it to the first input on the renderer. Now we're seeing a different type of shading there. Things don't really look great though, because we're still using the default light that's built into the renderer. So select the renderer and open the editor tools with Alt-Shift-R, and then under Add Light, choose Point Light. Then on the point light, move the position off to one side, up a bit, and back. So I'm going to go with something like 8, 3, and 5. So now let's take a look at the different parts of the material. On the mix fields, let's switch off the toggles for the second, third, and fourth inputs. You can also do the ones after that if you want, but they aren't hooked up anyway, so it doesn't really matter. So now we're just looking at what's coming out of this first one. On the diffuse contrib, let's bring up the albedo to brighten things a bit, and then you can dial in the roughness however you like. So that will kind of spread out, or for higher values, that will spread out the lighting a bit more on the surface versus kind of tighter highlights for lower roughness. Then pick a color for this. I'm going to keep it fairly subtle, so just like a little bit of a blue tint, but pick whatever looks good to you. Then go back to the mix fields and let's switch on that second input. And over on the Specular contrib, we can bring up the Fresnel again to brighten things, and then dial in the roughness however you like. So lower values here are going to make things kind of shinier, and higher values are going to spread out that highlight across the surface more. And for the color in this one, you can pick something different from what you're using on the diffuse, which will add some nice variation to it. I'm going to go with just a little bit of a orangey yellow tint there. I'm keeping these two with fairly low saturation since we're going to be adding more color in the rim highlights. So then let's go back over to our mix fields, switch on the third input. We can see something changed a little bit in there. If you try toggling it, you'll see a little bit of a change, but hard to tell what's going on. So let's head over to the rim contrib and change the color to a fairly saturated blue. This operator is equivalent to the rim shading feature on the Phong map. It adds colors to parts of the surface that are facing perpendicular to where it's being viewed from. It's similar to iridescence contrib, but without the rainbow coloring. Let's bring up the thickness to give it a wider edge on the sides there. To give us a little bit tighter of a view, let's go to the camera and maybe drop the FOV to 40 or so. We can bring it back out when we're done with this. On the rim contrib, we also have this blending setting, which will smooth out the edge of that rim area. So with a blending of 0, you get like kind of a hard line where things get cut off, and a higher blending will smooth things out. This operator is a great way to add some highlighting and color variation in your scene without having to add another whole light source. So then let's switch on the fourth one. So over on mixed fields, switch on the toggle for that last one. Right now, this is going to be showing up in the same places as the other one here. So you could maybe adjust the thickness to get it to kind of layer on top of each other. But it would be nice to be able to have it show up on different parts of the shape. So let's first pick a color for it. And I'm going to go with a pretty saturated purple, maybe a little bit reddish. And then we can bring up the thickness. So we're seeing it, but it's showing up in exactly the same spots as the other one. Fortunately, we can trick it into changing what it thinks of as the sides. Let's create a rotate normals operator and insert that between the second rim contrib and the mixed fields. This operator can be used within a material to change what direction it thinks the surface is facing. So try changing the different parts of the rotation there, and you can get it to show up on different parts of the surface. Keep in mind, though, that if you have it facing too much dead on to the, where the camera is, then things are going to get kind of washed out. So adjust that however you like. I'm going to go with something like 5, 16, and -17. And then for the color, I'm actually going to make that a little bit less pink and more purple. So you can spend some time dialing in the colors here if you want. You could try, different combinations, see what looks good, maybe, add a little bit more blue or something like that. So play around with it, see what looks good. And when you're done, we can move on to animation. So that's it for the actual contents of the scene. So the last step is going to be animating things. Now that we're done messing around with the material, let's go to the camera and bring our FOV angle back up so that we get a wider view. So I'm going to set it to 70. There are a few parameters that would be good to animate. On the Modulo Toroidal, we have the second part of the shift here, kind of rolls the arrangement of shapes. There's also the first part, but that kind of just rotates the ring, which doesn't really look that good to me, so I'm just going to leave that one and only animate the second part. Then on the Iterated Transform, there's the rotation here that we used before that has a lot of kind of fine detail effects there. And then there is the rotation that comes after that that gives us that kind of shape folding in and out of itself look. One thing to note here is that moving each of these axes gives us a pretty distinct kind of motion. And while we could just have it kind of continuously change all three of them at the same time, that might sort of dilute the effect of it, and we wouldn't get that variation in as nice of a way as if we were doing them separately. Instead, we can rotate each axis in sequence, and we may as well toss in the modulo shift into that sequence as well. It's still good to have some sort of continuous motion, though, so we can do that with the rotation on the Iterated Transform. We'll do that one last so that we can more easily see what's going on for the sequential parts of it, though. The sequential animation is going to use the same technique that I used in a tutorial from mid-2024, but it's been a little while since then, and it's a handy technique, so maybe it's a good time to revisit it. We're going to be applying this to 4 parameters: the shift, the second part of it, on the modulo toroidal, and then the 3 parts of the rotation on the rotate. Let's create an LFO chop and decrease the frequency to 0.5. Then we can change the type to pulse. Drag out from the output of that, and let's create a count chop. So every time the LFO pulses now, it's going to increase this number by 1. And with the frequency of 0.5, that's going to give us an increase of 1 every 2 seconds. Then drag out from the count and create a fan chop. For the channel names, let's replace that with R and then open square bracket, XYZ, close square bracket, space, and then shift. And then for the outside range setting, change that to loop index. So that gives us 4 channels that switch on in sequence one after another, and then it repeats as it goes through. Then let's stick another count chop after that. And now we have 4 channels that increment by 1 in sequence. And then as it continues, those numbers are going to get larger and larger. To smooth this out a bit, let's drag out from that and create a lag chop. And you could also use a filter for this, sort of up to you what you prefer in terms of the motion. Increase both parts of the lag parameter to around 1.5. So that will have it moving most of the time, but there'll still be a section kind of at the end of each cycle where it will be slowing down. You could also try changing that to something larger than the period of, the pulse, and then it would kind of continuously move, but that would sort of defeat the purpose of what we're going for here. So now we need to take these channels and get them into ranges that are useful for the different parameters that we're going to be applying them to. For the 3 rotation channels, those are going to be in degrees, so we're going to want larger numbers than we will for shift. So drag out from the lag and create a select. And then in the channel names, replace that with R, open square bracket, XYZ, close square bracket. So now we're just getting those 3 channels. Then drag out from that and create a math chop. And then coming out from that, add a null. On the math chop, let's bring up on the multiply add page, the multiply setting to 30. And then we can rename this null to rotation. Then let's take a copy of all 3 of those operators and select the math and the null, copy and paste. And then on the select, replace what's there with just shift. So now we're getting just that 1 channel. On the math for this one, let's drop the multiply to 1, and we can adjust that in a little bit. And we can rename the null to something like shift. I generally do try to name operators, at least they're going to be referred to from other places, like what we're going to be using for expressions and the parameters these are being applied to. So now let's head over to our rotate operator. And you can open the channel viewer on the rotation chop and then drag the first channel out of here onto the first parameter there, choose chop reference, and then we're going to do the same thing for the other 2. So that is doing something, but it's pretty subtle. So on the math that's being applied to the rotation there, we can bump this up to something like 90. So now we get a more distinctive movement. Then let's do the same thing for the shift. So go over to the Modulo Toroidal, look at the viewer of that shift null, drag that channel onto just the second part of the shift parameter and choose chop reference. And then on the math, you can dial it in. So looks like that is going way too fast. So we need to drop that down to maybe 0.1, 0.2. So you get a little bit of that rolling motion, but it doesn't go crazy. You can also make this negative. So switching that to negative 0.1, and then it will roll out from the center kind of instead of into it. Next, let's add the continuous motion on our iterated transform. This one's going to be a lot simpler since this is just simple continuous motion. Select the iterated transform and open the editor tools menu with Alt-Shift-R, and then under animate with speed, choose rotate XYZ. And again, since this is in degrees, we're going to need larger values. So increase the first 3 parts of the value multiplier to 30. And then you can adjust the different parts of the speed here so that it goes, at different rates. And you can use the multiplier to kind of scale the overall movement rate. And that's it for this scene. There are a bunch of things that you could do with the scene from here. You could use higher numbers of repetitions on the Modulo Toroidal to get some really, really interesting effects there. So, high on that first one gives you this kind of radial pattern, or high on the second one gives it, a very different look. So you can try playing around with that, different combinations, or you could swap in different shapes for the vertices, or you could adjust the U, V, and W for each of the shapes, or even control that with a field so it's different in different areas. Or you could add a modulo 1D after this, turn the ring into an infinite tunnel, or assign a different color to the vertex shapes so that they look different from the main ones, and lots of other ways that you could expand on the scene. Anyways, I look forward to seeing what you do with this one. If you post on social media, use the RayTK hashtag. And if you want to show off your work, tag me and I'll share it with the community. If you want to support RayTK development, subscribe to my Patreon. You'll get early access to tutorials, scene file downloads, including the one for this scene, and a bunch of other stuff. And even if you don't want to pay, you can subscribe for free as a way to get announcements about the toolkit. Feel free to reach out if you have any questions. I'll put links for that in the description. Anyways, thanks for watching, and make sure to like and subscribe.